Hello everybody, welcome back. In this video, I'll be introducing you to trigonometry, and we have a lot to cover, so let's jump right in. Alright, so trigonometry is it's basically like geometry and algebra mixed together. I'll just start by helping you find all of the sides of a triangle. So first of all, the one opposite of the right angle, we call the hypotenuse.
Hypotenuse.
Let's just say we have an angle right here. Let's say it's 36 degrees. I'm not sure if that's actually true, so don't quote me on that. But let's just say that. The one opposite of the given angle is the opposite side, because it's opposite of the given angle. And then the one adjacent to the right angle and the given angle is called the adjacent side, because it's adjacent to the angles. Alright. So now, after learning that, let's practice that on one more triangle. Let's say we have a triangle like this. Alright? Alright, so where's the hypotenuse? Well, the hypotenuse is opposite of the right angle, which means it's right here. And I'll just write hip for short. And where's the opposite? Well, it's opposite of the given angle, so it's here. Where's the adjacent? Well, it's adjacent to the given angle and the right angle, so it's here. So that is how you find and name the sides of a triangle. So now I'm going to show you a few trigonometric functions. Right? So so here are the three most common trigonometric functions you'll come in contact with: sine, cosine, and tangent. The way this functions works is we're going to input theta, which is the given angle. So if we input theta into sine, we're going to get opposite over hypotenuse. So if you're inputting the given angle, let's say the angle is 44 degrees. Well, the sine of 44 degrees equals the opposite over the hypotenuse. Alright, and the cosine, and by the way, you don't have to always write cosine, you can just write cos, and for sine you can just write sine. So you don't have to write this extra e and this extra ine, and then for tangent you don't have to write the gent, as long as you can remember that you're dealing with whatever function. And then cosine of theta equals the adjacent side divided by the hypotenuse. Alright, and tangent of theta equals opposite over adjacent. So hopefully you can sort of see where this is going. So let's say we have a triangle like this. Alright, and then if the given angle isn't actually given, but it's represented, you just represent it with theta, which is basically just a 0 with a line through it. Alright, so let's say this side equals 5, this side equals 6, and this side equals 7. Alright, so what do we get when we're doing sine of theta? Well, if we're doing sine of theta, we get 5 divided by 7, or 5/7. So, sine of theta with this particular triangle equals 5 over 7, or 5/7. Now what about cosine? Cosine is adjacent over hypotenuse. Well, cosine of theta equals 6 over 7. So cosine of theta equals 6 over 7, or 6/7. Now what about tangent of theta? Well, tangent of theta equals 5 over 6. Now what if theta is the other angle that isn't a right angle? What if it's this angle right here? Well, in that case, the sine of theta would equal 6/7. And the cosine of theta in this case, the cosine of theta would equal 5/7. Alright, and the tangent of theta equals 6/5, or 6/5. So I hope you noticed that because we swapped where the angle is, that the sine and the cosine, they swapped, and the tangent, its numerator and denominator swapped. Alright, so let's say we have a triangle like this. Let's say this angle is 78 degrees. Alright, and we're trying to find this angle, and we don't know any of the sides or anything. Well, we can still do this. And this is because all the angles of a triangle add up to 180. So if they all add up to 180, which means that these two are complementary because the right angle is always 90 degrees. Complementary? Alright. Which means that if we add the 90 degree and the 78 degree angle, we get 168. And 180 minus 168 equals 12. So this right here is a 12-degree angle. So now we know all the angles of a triangle. Alright, time for the big problem. I hope you're ready. Alright, so let's say this angle right here is 35 degrees. And we have a 90-degree angle. And we have the number 5. And let's say we're trying to solve for this side. Well, this side, 5, equals the opposite side because it's opposite of the given angle. The one opposite of the right angle is the hypotenuse, which leaves us with the adjacent side, which is adjacent to this angle and this angle. And what is the relationship that we can use to try to find out what the value of the adjacent side? Well, the relationship is tangent. And we have a given angle. We don't have theta, so we can say that tangent of 35 degrees equals 5/80j for adjacent. And what we want to do is we want to get 80j by itself. We want to get it by itself. So first things first, we can multiply both sides by the adjacent side. So this one and this one, they cancel each other out. And now we have the adjacent side times the tangent of 35 degrees equals 5. Alright, and I can divide both sides by the tangent of 35 degrees. So these two cancel each other out. And now we have the adjacent side equals 5 divided by the tangent of 35 degrees. So if we punch that into our calculator, we will get 10.55264808. And I encourage you to write that down somewhere because we will probably use that very long number a little bit later. But for now, we can just round that to the nearest hundredth. So we have 10.55. So we know that the adjacent roughly equals 10.55. Alright, now it's time to find the hypotenuse, the value of the hypotenuse. And we can do that in two ways, so I'll show you the first way. Alright, the Pythagorean theorem states that a squared plus b squared equals c squared. A and b being the adjacent and opposite side, and c being the hypotenuse. Well, I just like to find the exact value of the hypotenuse. I don't like all these exponents. So what I do is I take the square root of both sides so that this exponent and this square root sign cancel each other out. So now we have the square root of a squared plus b squared equals c. So now let's enter that into a calculator. Equals 11.677259116, and we won't be needing any of those extra digits, so we can just round this to the nearest hundredth, which will give us 11.68. So as you can see, I've cleaned up our triangle quite a bit, and you'll see that we have two angles that we know, and we have three sides that we know. Except if you know a triangle, you know there's three vertices. So we need to find this angle right here. And if you remember from earlier, all the angles add up to 180. So if we just add up the ones we already know, 90 and 35, we get 125. Then we subtract 125 from 180. We will get 55, which means that this angle is 55 degrees, and we've completely solved this right triangle. We've solved all sides and all angles. Thank you so much for watching. If you enjoyed this video, please give it a thumbs up and subscribe to my channel and hit that notification bell. If you disliked this video, please share it with somebody else because they might find it helpful. But for now, goodbye.